Alright, so I'm gonna look at energy losses in practical transformers. Okay, energy losses in practical transformers. So number one, unlike said earlier, due to transformation of energy, there are bound to be energy losses. But in a case where there is no energy loss, and that's why the transformer is called an ideal transformer. But it's very rare for us to see such cases where we won't have energy losses. So such a case, we have an ideal transformer. That means there are no energy losses. One, and the efficiency of the transformer is 100%. So in practical transformers, however, there are energy losses due to the following. So the following causes energy losses in practical transformers. Number one, eddy currents. Eddy currents, such currents produced by the varying flux cutting the iron core, reduce efficiency because they consume power from the primary coil. Energy is lost in form of heat in the iron core due to eddy current. Now, how is energy lost? In the sense that when there is a constant change in the magnetic flux, all right, and an EMF is induced. Okay, with time, we'll see that there will be a reversal in the poles of the magnet to the terminals of the electric field they are connected to. Such reversals will now bring about a negation to the law of magnetism, which states that like poles repel, unlike poles attract. Now, what brings about this reversal is eddy current as a result of constant supply of heat to the soft iron core. And I told us one of the way this can be reduced is by laminating the core or insulating the core. Number two, hysteresis loss. Hysteresis loss is wasted energy due to reversing the magnetization of the core. When you revise the magnetization of the core, what we have is hysteresis loss. Now, the core is made to go through a cycle of magnetization during which the alternating cycle of the primary current, during each alternating cycle of the primary current. So, when a cycle is complete, when an EMF is induced, when a cycle of alternating current is complete, a time is coming where we're having hysteresis loss, wasted energy, because as the cycle is being completed, the magnetic flux is changing, and as it's changing, EMF is being induced, and as a result of that, we're having wasted energy caused by hysteresis loss. Hysteresis loss is reduced by the use of special alloys in the core of the primary coil, or by the use of soft iron cores, so that the energy will be conserved instead of wastage. Number three, the heat loss or the power loss. I square R, the heat loss or the power loss. Because the primary and secondary coils have resistance, definitely V equals to IR, and P is equals to I square R. The power generated is directly proportional to the resistance. So some energy is lost in the form of power in the coils. This heat loss can be reduced by using thick wires. So the higher the resistance, the higher the heat loss or the power loss. So the only way to reduce that loss is to use wires of low resistance or low resistance coils. But the last one is leakage of magnetic flux. Some energy is lost due to leakage of magnetic flux. This arises because not all lines of induction due to current in the primary coil pass entirely through the iron core to the secondary coil. Leakage in the sense that this one is leakage in the coils, in the coils. There are some coils that when you wound them, when you wrap them around these cores, we see that most of them experience leakage. Maybe as a result of constant heat flowing through them, they experience leakage. And once there's leakage, we see that there will be heat loss. It's because they are ions, they are metal. Most of these coils are made up of copper. So when it's constant heat, you begin to experience leakage. Maybe some parts of the coils want to cut, something like that, like what happens in the generator when current is reversed back to the generator, as if some part of the copper coils want to cut or almost cutting, so there will be leakage in such processes. So this is reduced by special forms of coil winding or by efficient core design. So there are patterns with which they can wind the coils around the core, or there are ways they can do it in such a way that it will reduce the leakage. Now the formula for efficiency of a transformer is given by the power output over the power input times 100%, or the power in the secondary coils. Don't forget, secondary coils are also called output coils. The power in the secondary coils over the power in the primary coils times 100%. Calculations up next.